given the function f of x, where f of 3 is 0, answer the following questions. How many roots does the function have? So the first thing that we notice about this particular function is that it is a third degree function. So if it has an exponent of 3, right, the degree is 3, we know from our proof that we've been working on, the fundamental theorem of algebra, that if it has a degree of 3, then it can have at most 3 distinct roots. It can have at most 3 distinct factors, but that it will have exactly 3 linear factors. 3 linear factors. And that means, since each linear factor is going to tell us a root, that it is going to have 3 roots. Now, it's very possible, of course, that one of these factors has a multiplicity of 2. It could be x squared times x minus 1, but we do know that it will have 3 roots. Then we want to find all of the roots. And so here we know that we have one of the roots, right? We know that x equals 3 is a root. So we need to find 2 more. Okay? Now, looking at our function here, looking at f of x, we know, looking at it just in this form here, that we can't tell the roots just by looking at it. But there is a form that we could transform f of x into, which would allow us to know all the roots. So that would be factored form. And so our goal, what we want to do, is we want to factor f of x. Right? We want to write it in factored form. And so we'd like to write all the factors out. Well, we have one factor. Right? We know that x minus 3, right? If x equals 3 is a root, we know x minus 3 is a factor. And so we'll have x minus 3, and then we have 2 other factors that we are going to be looking for. We could give them a name. I might call this P1 and this P2. And in order to solve, I'm going to divide each side by x minus 3. So on the right-hand side, I'm just going to have my 2 factors that I'm looking for, P1 and P2. And on the right side, I'm going to have the division that will take place between my original function and x minus 3. I'm going to divide out that factor. So the first step, now if this is something that you need to review, it might be a good idea to go back and take a look at the lesson that is posted on polynomial division. I'm going to go through this rather quickly. X goes into negative 4x cubed, negative 4x squared times. So that will give me a negative 4x cubed. And then I multiply by the negative 3, which will give me a positive 12x squared. If I could write that. Let's give it one more try. X squared. There we go. And now I subtract. I'm going to do this in a different color just to see very clearly. I subtract everything. So that will turn this into a positive and this into a negative. And so negative 4x cubed plus 4x cubed is going to cancel. That equals 0. 24x squared minus 12x squared is going to be 12x squared. Negative 44x plus 24. So now what I have left over, of course, that I still need from the future multiplication here, is that I need a 12x squared. So what's going to give me a 12x squared? Well, by multiplying x by positive 12x. 12x squared minus 36x. I subtract everything. So this will turn into a negative, and this will turn into a positive. So these will cancel. And here I'm left with negative 8x plus 24. X goes into negative 8x, negative 8 times, and this is going to give me negative 8x plus 24, which is exactly what I wanted. So when I subtract, positive, negative, and I'm going to cancel everything, which is exactly what I'd expect because it should go in evenly. And now I can complete my work over here. So I know that from my division I get negative 4x squared plus 12x minus 8. Now notice how my work, this is done to the side. Right? This is just division. It's not rocket science. It's not some sort of, innovative, cutting-edge technology. This needs to be done. This is scratch work. The work that I want to see, that anyone who's reading your work, or that if you're solving some solution for something important, this wouldn't really be shown, right? I trust that you can do division, and I will obviously know, I will be able to check whether your division is correct, but I'm not going to go and look through all of this over here, right? Division is a useful tool, and we're using it to solve for our missing factors. It may be something that's tricky, and that's why you need to practice it, but it should still be done off to the side. All right, so we want to take our quadratic polynomial now, and we want to turn it into two factors, right? We want to factor it. And so I'm going to move my equal sign to give me a little more space here. So I have polynomial 1, factor 1, and then my second factor. And think about this quadratic polynomial here. What will make it easier to factor? What types of quadratics have you factored before? And what should come to mind is that if you just have a leading term, and I'll write it up here, if you have some leading term, say x squared, as long as this term has no coefficient here, it makes it a lot easier, okay? So go ahead and factor out, see if you can factor out this leading coefficient, this negative 4. And it turns out that you can. So we can factor out a negative 4, and now I'm going to have x squared minus 3x plus 2, which is easily factorable. This is really easy to factor. Okay, and so now I can split it up into my two linear factors pretty easily. I'm going to have negative 4 times, and the first factor, I guess I can just write it like this. The first factor has got to have x plus or minus some number, and the second factor will have x plus or minus some number. And these last two terms, of course, must multiply to give me a positive 2. So think about all the possible things you can multiply that will give you positive 2. And I think you'll notice that 1 and 2 are our only options, 1 times 2. But consider the fact then that they have to add up to negative 3. So we need to realize that we can also multiply negative 1 and negative 2 together. That will also give us a positive 2, but then when I add them, it will give us a negative 3. So it'll be x minus 1 and x minus 2, and those are the two factors that I'm looking for. Now I want to call to our attention one more way that we can complete these last couple of steps here. So in trying to factor this quadratic, it might be that we can't find some common term to pull out. Maybe negative 4 doesn't factor out evenly for any of these. And so, we might pull out the first term, we might pull out negative 4, and we might get some funky something left over, right? We might have x squared minus 3.5x plus 2 or whatever. And that's going to be a little tricky for us to factor. So we can always, instead of factoring, remember, the factors are linked to the roots, right? Given these two factors, I know the roots of this quadratic. their roots are x equals 1 and x equals 2. So if I can find the roots of this quadratic, I could also find the factors. So the alternative move would be to take your quadratic and set it equal to 0, right? So negative 4x squared plus 12x minus 8, set it equal to 0, and then solve for x using the quadratic formula, which of course will be negative 12 plus or minus the square root. Now b squared is 144 minus 4ac. So 4 times 4, I'll show you what I'm doing. So I have a negative 4 times a times c. So negative 4 times negative 4 will be positive 16 times negative 8. Well, what's negative 8 times positive 16? It's going to be a negative. And then I have 16 times 8. 10 times 8 is 80. 6 times 8 is 48. So it'll be 128. So 144 minus 128, that of course is going to be 16, all divided by 2a, which is going to be negative 8. And then you can simplify this further. You're going to have negative 12 plus or minus. This all becomes 16. Square root of 16 is, of course, 4 divided by negative 8. And the two answers that you get here are, not surprisingly, 1 and 2. So think about what you now know. You know that the roots of this quadratic are 1 and 2, meaning that the linear factors are, of course, x minus 1 and x minus 2. And you might be wondering, where does this negative 4 come from? The negative 4 is not a part of the factors. You would still have to factor it out. If I were to find the roots of this x squared polynomial without the leading coefficient, I would get the same roots, and you can try that. If you were to set x squared minus 3x plus 2 equal to 0, you'd still get 1 and 2. Remember, what we're really looking for are the factors. This negative 4 isn't quite as important. It will just multiply the values. So now we can move on to part C. Well, actually, let's write our answer out to part B. What are the roots of our function? Well, the roots, we have x equals 3 from our first, what we're given in the equation, or I'm sorry, in the problem, f of 3 is equal to 0. And then from the 2 that we've just found, from the 2 missing factors, we have that x equals 1 is also a root, and x equals 2 is also a root, and so we found all 3 roots. So now the next part of the question asks me to write f of x in factored form. So what's f of x in factored form? Well, it's all the factors. So let's take first the 2 factors that we found. We'll include the negative 4 here. We have negative 4 times x minus 1 times x minus 2 times x, the one that we have from the beginning, x minus 3. And so now I can use this to complete part D, which is just to sketch a graph. I'll do that up here. Of course, you have more space on your paper, so you can probably make it much more neat and tidy. This is, of course, part C. Now, part D, I want to make sure that I have each root. So x equals 1 is a root, x equals 2 is a root, and x equals 3 is a root. So this is a third degree polynomial. So what's the basic shape going to be? Well, notice you can either look back up here or you can look at your factored form. The leading coefficient is a negative 4. It's negative. So the basic shape of your polynomial, follow the pointer here, instead of going like this, instead of sort of snaking up from left to right, it's going to flip. So it's going to snake down from left to right, right? It's going to reflect over that x-axis. So I'm going to start, it's going to come down, it's going to cross at negative 1, it's going to come up, cross through at 2, and then cross through at at 3. Notice that I know it will pass through at each root simply because at each root